Welcome back to another episode of Learning Integration. This episode I will be talking about integration by parts and focusing on the exponential functions like a to the power of x. So here we have a function a to the power of x, and if we anti-differentiate that function, we get a to the power of x over ln of a. And here is Leibniz's notation for the integration by parts. Okay, you can pause that if you want to have a look, but I'm going to continue with our first example. So here's our first example, dy over dx, which is the derivative of, let's say, 7 to the power of x ln of x. Now, we got to find the integral of both sides. Integral of the derivative is the function, and the integral of this side we'll write as such. Now, we have a function times a function. If we find the integral of what's inside the bracket, if we find the derivative of what's inside the brackets, will it help us eliminate the first function? The answer is no, therefore we use by parts. Which is pretty obvious, you're here to watch by parts, but just that's the process. Anyway, so we pick over here, we have a u and a v dash. We need a u dash and we need a v. Therefore, we need to turn this u into a u dash and this v dash into a v. That means that one of these we have to pick one of them to be u, and when we derive it, it has to simplify. And one of these we have to be g dash of x, and the one we pick to be that has to, well, not really simplify, but has to not make a mess if we go to, because we're going to have to find the integral. Now, that might make not much sense, but essentially, this is the parts we have and what we need in order to complete the formula. Okay. So one of these we've got to call g dash, and one of these we've got to call f of x. Okay. In my experiences, whenever I see, in any other case, the one that simplifies the most, or that simplifies the easiest when derived, I pick to be fx, but whenever I see an ln of x, I go straight to picking that as fx. Because ln of x, when you derive it, you get 1 over x. If I was to find the integral of ln of x, it would be a mess. But 7 to the power of x will be our g dash of x. And if we were to find the integral of that, just like on the front, 7x over ln of 7. Plus c, if you're doing a normal question, but I don't like to do my plus c's till the end. So I'm not putting it in here. Okay, makes sense? Hopefully. So, formula states, if I can fit it in, we're saying this is the function we started with, which was 7x ln of x dx. So we're saying that is that. Therefore, we can fill in this. U. Oh, here I am making mistakes. U dash, v, and v dash. I just did a video of this on Lagrange's notation, so I use Lagrange's instead of Leibniz's. But same thing applies. They're still the same. U dash, v dash. Don't panic. U. We're saying u is ln of x. V. We're saying v is 7x over ln of 7. Subtract the integral of derivative of u. Derivative of u is 1 over x, multiplied by v. We're saying v is 7 to the power of x over ln of 7 dx. Okay? I hope this didn't throw you off. It shouldn't. F of x is the same as u, and it's all, these are all the equivalent. This is just different notation. So if you understand how this really works, it should make a difference. If it confused you, I'm sorry, it won't happen in the next question. But anyway, we have our formula written up. This is good. This means we can now solve it. Okay. ln of x multiplied by 7 to the power of x over ln 7. That just looks like this. Subtract. Well, we can, this ln of 7 essentially is 1 over ln of 7 multiplied by 7 to the power of x. Therefore, it'd look like 1 over x multiplied by 7 to the power of x multiplied by 1 over ln of 7. If 1 over ln of 7 is a number, which it is, multiplication by constants means we can bring it out the front. And therefore, 7 would be on its own. We're just taking this out the front. But we can multiply 7x onto the x, and it will look like such. Seven to the power of x on x, because I just moved it across. Okay. Okay, well, I don't know if you know this, but 7 to the power of x on x, I'll just write this up because this is still part of the equation. Find the integral of this. Okay, so the integral of 7 to the power of x on x is, it looks a bit funny, but it's I ln of a multiplied by x. Okay. No plus c in it because it's included in the integral. I'll explain that in a minute. I will add plus c onto the end, but I want to explain what this is first. EI ln of a x. What does that mean? That is basically saying the integral of 7. This here just is the equivalent of saying this. Including the integral sign, including the 7 to the x over x dx. That whole bit on the left, on the right of my hand, up the top corner, is the exact same as that. That's how they write it. Not that, that's how they write it. How do they get that? Well, if you watched a previous video, I had EI x. That equals the integral of e to the power of x on x dx. Now, I don't know, this might seem difficult, but a to the x on x. Why would that equal EI ln of a x? Well, how do we get an a here for 1? Just, it looks a bit like this. We have REI. I'll do this side first. E to the power of ln of a x over x. This right here is the same as that. The e to the power of ln of a, the e cancels out the ln and the ln cancels out the e. That's why we're left with an a to the power of x. I know it looks funny because we have ln of a multiplied to x, but when you get rid of these, the a comes down and the x stays up and it looks like this. It may be a bit confusing to wrap your head around, but that's why ln of a x. That's why it's that. Because before, EI, which just means the integral of e with respect to x, just means that the variable is x. On here, it's e, because it is e, but it's to the power. The power is ln of ax, which it is. The reason it's an x here is because the only power is an x. the reason there's an ln of ax here is because the power is ln of ax. The only reason you don't write this here is because these equal the same. It's much easier to write a to the power of x on x than it is to write e ln of ax. These equal the same thing. There's not really much more I can say. I hope that makes sense. Google it. You can Google this sort of stuff and it will come up. The integral of exponentials, if you find the right page. So therefore, that's what that means. Therefore, 7 to the power of x over x, there wouldn't be an a there. That's my bad. There would be a 7. Now that doesn't look neat, but I'll rewrite that. So therefore, we have ln of x multiplied by 7 to the power of x on ln of 7. Subtract this on top of that, which would be e to the power, ei ln of 7x over ln of 7 plus c. I only added the c on because there was no real way I could add a c through this, and I didn't want to do it at the beginning, so I'm just going to add it on at the end. Okay, so now that's basically it. You can, if you want to, you can make it look a bit neater and just join them. So you'll have 7x minus ei ln 7x ln of 7, because they have the same base. And that is the integral of 7x multiplied by ln of x. Okay. Let's go on to another example. Hopefully that didn't confuse you too much. So we have example 2. Start off with our function. And it equals x multiplied by a to the power of x. Okay. So we find the integral of, if we derive whatever's in the brackets, will we get something to help get rid of this x? The answer is no. Therefore, we use by parts. I'm just going to write the a. I don't need to write a number. This represents a number, and it doesn't affect the working at all. So the integral of this side and this side will look like this. Now we got to pick one to be u and one to be v dash. I won't mess it up this time. We've got u dash, what they equal, and we've got v, and we've got v dash. Now, the one that simplifies the most, there's no ln of x, so I don't care about that anymore. Whichever one simplifies the best when derived, that's what I want to be u. That will be x, because x, if I derive it, I get 1. That's good news. A to the power of x will then have to be v dash. And the integral would be a to the x on ln of a. Plus c, but like I said, I don't like adding it in here. Just this spot, I don't like adding it in. Okay? So if I rewrite this, we get, and in the formula, if I rewrite it like the formula at the beginning says we need u multiplied by v. U is x, v is ax to the x over ln of a. Subtract the integral of u dash multiplied by v. U dash is 1. V is a to the x over ln of a. And the reason I didn't write the 1 in is because there's no point. 1 multiplied by this is this. It's the same thing. Now that we have our formula, we can work to solve. Okay. So, here's the easy part. This is much easier, this question. So, we have the x, we can multiply it on top. subtract, well, because a to the x over ln of a, the 1 on ln of a I can bring out the front because it's a constant. Multiplication by constants rule let me do that. I'm allowed to do it. I can't speak English. I'm a mathematician. But shush. That's what I get. I multiply the 1 over ln of a at the front because it's a number, and I leave the a to the power of the x inside. And I'll write what we started with, which was a to the x. Probably wasn't in that order, but it doesn't matter because we're multiplying them together. We can switch them around however we want. Anyway, let's do the question. Let's solve it. So this stays the same. X, a to the power of x, ln of a. Subtract 1 over ln of a. The integral of a to the x is a to the x on ln of a plus c. Okay, this bit stays the same, except I buggered it up. Subtract, what's 1 over ln of a multiplied by ax over ln of a? It's ax over ln of a squared. Plus, minus, because it's a negative we're multiplying in. So a negative 1 over ln of a multiplied by c over ln of a. This stays the same, x multiplied by a to the x, ln of a, minus ax ln squared of a. And I'm going to say plus h, only because I'm going to make h equal negative c over ln of a. Because I said this is true. This here equals that. Now, technically this is done, but if I wanted to simplify it further, how would I do that? Well, I'd want to multiply ln of a on top, so I could have ln of a squared to match this. Ln of a multiplied by x multiplied by a to the x, subtract a to the x all on ln a squared. Because if I multiply ln of a on the top, then I have to do it on the bottom. It would equal the same thing, but it would allow me to join the bottoms, which is what I just did. Okay, plus h. Now, I'm going to write what we started with in the proper order that I started with. A multiplied by a to the x, the integral equals a to the x ln of a x minus 1 over ln squared of a plus h. What did I do there? I just factored out a to the x, because we have an a to the x multiplied to this and an a to the x multiplied by the negative 1. So I just brought it out. And that there is your answered question of what is the integral of a to the x multiplied by x. And there it is. Thanks for watching. I hope you learnt something, and have a good day.